Hi, my name is Dury Long, and today I am going to be sharing our project, Non-Digital Hands-On AI Learning Resources for Middle School Students. I have worked on this project in collaboration with my PhD students listed here, as well as a number of undergraduate research assistants and post-baccalaureate research assistants also listed here. We are all members of the Creative Interfaces Research and Design Studio at Northwestern University. Our goal for this project has been to design unplugged, in other words, non-digital hands-on activities to foster AI literacy amongst middle school age students, so 10 to 14-year-olds. And why are we interested in doing this? We have seen a need for rapid development of K through 12 AI learning resources for use in both formal and informal learning environments. But there are some key challenges for developing and adopting these resources. First, the cost of expensive materials, such as expensive AI technologies or subscriptions, can be prohibitive for parents or teachers. There are also permissions that are required to use certain technologies, which can pose obstacles when introducing novel and emerging technologies in schools and classrooms. Instructor and parent expertise in teaching about AI varies widely, and there's a need for activities that do not require a lot of prior experience or knowledge of AI. And finally, there is time needed to cover the new topics. People have limited time. Teachers are already responsible for teaching a set curriculum. And so there's limited time to add in new topics related to AI. And so in our work, we are exploring a solution to some of these challenges. We identify a need for standalone grab-and-go activities that instructors can easily insert into their curriculum and parents can easily teach their children. And so in response to these challenges that I just described, our solution or our proposed solution involves paper-based activities that are low cost. These non-digital activities also don't require purchasing or permission to use specialized technology. Lesson plans can be led by adults with little prior knowledge of AI, and they don't need to have any prior knowledge of how to use particular computing interfaces or software. Time-scoped activities can be used in environments with time constraints and competing curricular needs. And we also have a focus on creating activities that intersect with other core disciplines so that we can teach about AI not just in computing classes, but also slot activities into other disciplines such as art, social studies, or science. In our activity design, we focus in particular on incorporating elements or opportunities for embodied interaction and personal identity. And this is because middle schoolers are in the process of forming their identities and self-perception while they're interacting with these emerging new AI technologies that are shaping and influencing how they're viewing themselves. So our activities aim to empower middle schoolers to learn about AI through the lens of their own bodies and identities. That brings us to the research questions driving this work. First, we ask, how can we design a set of unplugged activities that empower young adolescent learners to learn about AI through the lens of their own bodies and identities? Second, we ask, how do adolescents and educators perceive unplugged AI literacy activities? And finally, we ask, are unplugged activities effective at fostering middle school learners' AI literacy? So focusing in first on our first research question, which is focused on design, we have designed a number of different activities that fit this description. Each activity is formatted including a lesson plan that identifies key concepts to help teachers and parents in conveying the lesson. So key vocabulary, an activity guide, a discussion guide, key learning objectives, as well as opportunities for extending and adapting the activity. Each activity also includes a set of publicly freely available resources, including slides, printed materials, other materials that are required to build or construct the activity, and links to learn more. In total, we have developed 13 different unplugged activities designed to teach about different AI concepts. Our activities have coverage over sort of three different areas of AI literacy. The first is introducing AI, so helping understand what AI is at a high level and understand some of the key concepts or ethical issues to consider surrounding AI. The second is representation and reasoning. So being able to take a deeper dive into how AI represents knowledge and how it reasons about things, and how that might differ from how we as people do. And finally, AI ethics and data privacy. So through the lens of their own bodies and identities, what sort of ethical issues need to be considered for society in relation to AI, and what do young learners need to think about in regards to data privacy and AI? So I'll walk through a few examples of the activities within each of these categories. I won't cover all of the activities that we've developed for the sake of time, but I'll give you a few highlights. So within the space of introducing AI, we have developed an activity called Introducing AI, which is focused on engaging learners in exploring what is AI, where have they used it before, how do they feel about it, how does it work. So this is a very high-level introduction to AI and can be used to kick off a class, unit, or workshop with other activities involving AI. So to do this, learners engage in a worksheet activity where they can sort through a deck of cards that has a list of AI examples, so real-world AI technologies, and they can identify AI technologies that they've interacted with before. They can then map them on this sort of emotional scale to think about how they feel about different AI technologies. Do they inspire curiosity or optimism, or do they cause them to worry or have fear? In addition, learners construct a sort of cube to imagine a future AI technology. So they look through another set of cards to identify an input, algorithm, and output for an AI technology, and then identify a potential advantage and disadvantage of that technology in society, doing sort of an initial dive into thinking about societal impact and ethics surrounding AI technologies. Within the next category of activity, representation and reasoning, we've developed several different projects. The first that I'll highlight today is Kernel Quest. In this activity, students learn about how convolutional neural networks make sense of images. So CNNs break images into small pieces and identify patterns like edges within those images. And in our activity, learners are taken on a quest to identify a series of imaginary creatures called quirkies, which you can see here, using a custom kernel lens tool, which is just a box that we've built with wood and polarizer sheets, all freely and cheaply available online. And this allows learners to move a small viewport freely over a large picture, revealing only the portion of the picture directly under the viewport, while the rest remains hidden. And while they do this, learners are guided to make observations about features of the image and identify patterns. So they're able to sort of put themselves in the shoes of the kernel quest of the convolutional neural network. The next activity we've developed within this space is called LLM Mad Libs. And in this activity, which intersects with math education, learners can learn about independent and conditional probability alongside how large language models work. So students engage in a Mad Libs-like worksheet activity where they use dice and a provided slide deck to explore how large language models use probability to generate words to complete a sentence. And we also include an exploration of how bias appears in LLM-generated texts and an introductory session on how large language models are trained. Finally, the last activity I'll highlight within this space is monster mapping, where we engage students in learning about unsupervised machine learning and k-means clustering through a paper-based activity in which they cluster different types of colorful monster characters according to their features. This activity has intersections, again, with math education objectives of learning how to read and represent data on graphs. Finally, within the space of AI ethics and data privacy, we have developed a couple of different activities, including data brokers, in which learners engage in an interactive game where they work together to figure out which users to target with ads for different products via an AI algorithm. They use a sample database that mimics the type of data a company would acquire from a third-party data broker in order to decide how to allocate their funds for ads, which prompts them then to reflect on different user identities and whether algorithms can truly know us and our preferences. And finally, we've developed EthiQuest, which is a card-based activity where teachers, learners, or parents can select cards that prompt discussion and debate related to generative AI ethics. And what's unique about this card deck is that all of the issues are written to be relevant to 10 to 14-year-old kids. Focusing on our latter two research questions, we have conducted a number of studies to evaluate how effective our activities are at promoting learning and how teachers and kids perceive them, including several of our activities were used in a middle school AI summer camp that was run in North Carolina with 22 students. And from the data collected surrounding these activities, which were mostly focused on introducing AI and ethics, exit ticket interviews at the end of each day indicated learning about key AI concepts, such as the ability to identify examples of contemporary AI technologies and recognize AI's strengths and weaknesses. Teacher feedback also indicated that students enjoyed the activities and that kids were more focused on AI concepts during unplugged activities than other plugged activities that were involved in the summer camp. And finally, teachers found that several of the activities were particularly useful at filling gaps in the schedule with relevant content, affirming our goal of developing easy-to-use grab-and-go activities that can be easily slotted into variable time periods in a curriculum. More recently, just this past month, we have conducted a study with 10 to 14-year-old children and their parents who were recruited for a 1-hour workshop in which they engaged with 2 different activities. Recruited through the Griffin Museum of Science and Industry member mailing list. We recruited 20 kids. And we found that our data analysis is still ongoing since we conducted the study recently, but our initial impressions indicate that the tangible simulations of AI reasoning processes supported understanding of key AI concepts, such as that AI classifies images by picking up on key features and patterns, and the idea that AI is not all-knowing. We also have identified some areas for improvement, which I'm sure we'll expand upon as we continue our data analysis. But we are interested in improving knowledge transfer to new contexts and also ensuring that we are still accurately conveying how AI works, even when the algorithm is simplified for the unplugged activity. This work has resulted in a number of different outputs, including several publications in progress. It is also having a broader impact. I want to note that all of our activities are publicly available freely online, and we'll continue to update this website as we finalize the activity designs. And they've already been used by over 42 children and 15 teachers across professional development workshops and summer camp and the students that have participated in our studies. If you want to learn more, please check out the Unplugged activities. The full set of 13 is on our website, and you can also check out our lab website or reach out to me personally. Thank you so much.